Hi everyone, my name is Meirah, and today I'll be talking about the preliminary results from my master's thesis in this talk titled, How Much Do Flash Flooding Events Outside an Excessive Rainfall Outlook Matter? I wanted to start by going over what an excessive rainfall outlook, or an ERO, is. EROs are issued by the Weather Prediction Center and are a forecast of the probability that rainfall will exceed flash flood guidance within 40 kilometers of a point, where flash flood guidance is an estimate of rainfall over a given time duration that could cause small streams to flood. EROs are primarily based on quantitative precipitation forecasts, but also take into account antecedent conditions such as soil moisture, stream flow, land use, and terrain slope. This research will specifically focus on day 1 EROs, which are valid 12Z on the day they're issued to 12Z the next day. They are the most accurate compared to day 2 and day 3 EROs because of their proximity to the event. And on the right-hand side of the screen is an example of a day 1 ERO outlook. This one is valid from 12Z October 8th, 2018 to 12Z the following day. And the white on the map represents areas where flash floods are not expected. The green regions show that there is a marginal risk of flash flooding, or a 5 to 10% chance that rainfall will exceed flash flood guidance within 40 kilometers of a point. And these categories go all the way up to high risk, in which there is a greater than 50% chance of rainfall exceeding flash flood guidance within 40 kilometers of a point. And so EROs are really important because flash flooding, first of all, is very costly and very deadly. Flash flooding is the most deadly type of flooding, and flooding overall is one of the most damaging weather-related phenomena. EROs, unlike rainfall forecasts, do a really good job of conveying impacts and risk of flash flooding across the continental United States. And finally, EROs are an important situational awareness and planning tool for decision makers such as the public, local weather stations, and emergency managers. So the WPC has verified the ERO at different risk categories by using flash flooding proxies and observations that are part of the Unified Flooding Verification System, or the UFVS. The UFVS, which will also be used in this research, contains 4 flash flooding proxies and observations, which I will just refer to as flash flooding events. And these are stage 4 analysis exceeding flash flood guidance, stage 4 analysis exceeding 50-year average recurrence interval, USGS river gauge observations, and National Weather Service local storm reports. Fatalities and damages have also been examined by the WPC at different ERO risk categories. Between 2014 and 2017, high risks were only issued on 4% of days, but these days accounted for 44% of flood-related fatalities and 86% of flood-related damages. And so, although the WPC has done a lot of work to verify ERO risk categories, one area that has been less studied is flash flooding events that fall outside of an ERO and their associated damages. And so this leads to our research questions, the first of which is, what are the spatial and seasonal distributions of flash flooding events missed by EROs? And we follow this up with, what are the spatial and seasonal damages associated with missed flash flooding events? So essentially, we're asking, well, if an ERO doesn't forecast a flash flooding event, did this flash flooding event cause any damage? So to answer these questions, we use daily data spanning from September 1st, 2016 to August 31st, 2020. And we chose these dates because the marginal risk category was only introduced to the ERO in August of 2016. And we use gridded net CDF datasets containing day 1 EROs and flash flooding events from the UFVS. At the bottom of your screen is an example of the methods that we used. So on the left are a day 1 ERO and all flash flooding events from the UFVS. And this example is valid from 12Z August 20th to 12Z August 21st, 2018. On the right are the flash flooding events that fall outside of an ERO. And because the WPC interpolates these flash flooding events in the UFVS to a 40-kilometer radius, you can see that fractions of flash flooding events can be outside of an ERO. We then extracted the counties that overlap missed flash flooding events using county-level flash flooding property damage data from the storm events database from NOAA. You can see these counties represented here in blue. And we completed this analysis for every day during our study period. So to answer our first question, what are the spatial and seasonal distributions of flash flooding events missed by EROs? We aggregated missed flash flooding events by season. Because we use daily data, this can also be thought of the number of days in which the flash flooding event was missed. So you can see that summer and winter have these pretty distinct regional patterns, while fall and spring, compared to fall and spring, and summer experiences more missed flash flooding events compared to other seasons. Missed flash flooding events are concentrated directly east of the Rockies in summer, down here in the southeast, up in the Appalachian Mountains, and also in the Ohio River Valley. There's also a relatively high number of missed flash flooding events out here in the southwest. And putting this into the context of other research, we know that flash flooding events reach a maximum in the summer, primarily due to precipitation from mesoscale convective systems. The North American monsoon in the southwest and tropical systems also contribute to summer flash flooding. And as mentioned earlier, EROs are primarily based off of quantitative precipitation forecasts, which still exhibit challenges forecasting convective precipitation. So this combination of more flash flooding events in the summer and difficulties forecasting summer convective precipitation is a possible explanation for why there are more missed flash flooding events in summer. In winter, the West Coast, you can see here, also has a number of missed flash flooding events, and the combination of atmospheric rivers that are prevalent on the West Coast during winter and the terrain of the Sierra Nevadas and the Cascades could be an explanation for the high number of missed flash flooding events in this region and season. So after getting an idea of where missed flash flooding events are concentrated seasonally, we move on to examine what the damages associated with missed flash flooding look like. And there are many different ways to represent damages associated with these missed flash flooding events, such as the number of days there were missed damages in each county, or the dollar amount of missed damages. Here we decided to use the dollar amount of missed damages as a percentage of the dollar amount of total damages from flash flooding in each county, as we felt that this better represented the impact of damages associated with missed flash flooding events. So all of the white counties on these maps indicate that there were no damages from flash flooding reported. Yellow indicates that there were damages from flash flooding, but all of the damages were captured by EROs, and this gradient goes all the way up to red, where more than 75% of damages were missed by EROs. And there are a fair number of counties with missed flash flooding events in both spring and summer. In the summer, high percentages of missed damages cluster in the Ohio River Valley, along the Mississippi River in the south, and then also out in the southwest. And interestingly, the southwest does incur damages from missed flash flooding events year-round. And another thing to note is that missed damages do not necessarily follow the same spatial pattern as missed flash flooding events that we saw on the previous slide. One possible explanation is that in some places, such as directly east of the Rocky Mountains, and then up in the Cascades, there is just less infrastructure, and with less infrastructure, there will be overall less damage. Another possible explanation is the storm events database, although likely the most comprehensive database available for analyzing flash flooding damages, is not complete. So because counties in the Southwest tended to have a high percentage of missed damages year-round, we wanted to take a closer look at this region. And the storm events database provides a description of the cause of flash flooding events. And using this, we were able to attribute 72% of missed damages and 68% of damages captured by EROs to flash flooding events associated with the North American monsoon. And because these numbers are pretty similar, this could indicate that the North American monsoon causes flash flooding damage in the Southwest, regardless of whether or not these flash floods were forecast. And then overall, between 2016 and 2020, flash flooding damages totaled nearly $5 billion. However, these flash flooding damages that were missed by EROs account for only $170 million of these dollars, or just 3.4%. So there are a number of different ways that this analysis could be built on, but one area that we're hoping to explore further is what do damages look like spatially at different ERO risk levels. So the WPC did find that 86% of flooding damages occurred on a day when a high risk was issued, but where exactly do these damages occur? Do they primarily fall within the high risk contour, or do they fall outside of it? And as we approach this problem, one thing that we will need to account for is the fact that the issuance of risk categories by the WPC within an ERO varies significantly spatially and seasonally, as noted in this recent paper by Erickson et al. In 2020. You can see this is an example of the issuances of the slight category. You can see there are certainly a lot more issued during the summer, specifically in the Midwest. And in the spring, this shifts towards the south and really lessens in the fall and winter months. So it will be important to normalize damages by risk category. So overall, flash flooding events missed by EROs and their associated damages are highest in the summer. The Southwest US has a high proportion of missed damages, possibly due to convective precipitation caused by the North American monsoon. But overall, damages from missed flash flooding events account for very little of total flash flooding damages, just a mere 3.4% of the total dollar value of flash flooding damages. And we do hope this work, this current and future work, will help provide a comprehensive overview of how ERO spatially and seasonally capture flash flooding and their associated damages, which could potentially help improve ERO forecasts in the future. And thank you for listening.